So chemical equations are always of the general form, so generically speaking, A plus B to give C or C plus D. This is a way we can represent a chemical equation. And of course, over here on this side, we have the things that react with each other to form things that are produced. And so we can use those words. The things that react are called reactants, and the things that are produced are called products. So the names seem to make sense to me, and hopefully to you. Okay, so what's an example of something like this? Well, if I take some hydrogen gas, that little G in parentheses means gas, and I react it with some nitrogen gas, I'm going to get a substance called ammonia, which is also a gas. And if you look at this is a chemical equation. Hydrogen gas, nitrogen gas, they are reacting to form the product, which is ammonia. Now, a couple of things that you need to pay attention to, and that would be looking at the symbols for these elements. Okay. Now, over here on this side, we have hydrogen. Notice that there's a little subscript here. It's a 2. Likewise here, there's a subscript of a 2 for the nitrogen. Well, one of the things we'll talk about in the fall are the so-called diatomic elements, and they occur in nature as 2 atoms that are bonded together. So, for example, H2 means I have a hydrogen bonded to another hydrogen. So really, that looks like an N there. Sorry about that. So that's a hydrogen molecule, and hydrogen in nature exists as that. And nitrogen over here, same thing. We'll make it a little bit bigger because nitrogen's a little bit bigger. So we're reacting those 2 things, and we're producing something called ammonia, which looks like this sort of, we'll get into the structures of things as we need to. Okay, so roughly this is a sketch or a cartoon of what's going on in this chemical reaction. Something should be bothering you right away, though. On this side of the arrow, on the reactant side, I have 2 hydrogens. They're bonded together, but nonetheless we have 2 of them. And on this side, we have 2 nitrogens. As I said, they're bonded together, but there are 2 nitrogen atoms bonded together. When I look on this side of the chemical reaction, the product side right over here, what we end up having is we have 1 nitrogen and 3 hydrogens. So something's not adding up here. I mean, don't forget, think about algebra. If there's an equal sign between the left and the right side of an equation, well, those 2 quantities have to be equal. They have to balance. And that's the same thing here. We can't write an equation like this. I mean, we can write it, but it's not correct. We have to make sure we have equal numbers of atoms on both sides of the equation. So how do we do that? We never ever touch the subscripts, never, because those represent the correct formulas for the chemical compounds. What we do is we use coefficients, and the coefficients go, of course, in front of the chemical compound. And let me show you what I mean by that. Okay, and this is where you kind of have to think of some of the things you learned in algebra. Let me go down and rewrite this equation once again. H2 plus N2, and these are both gases. G stands for gas, L stands for liquid, S stands for solid, if you should see that, AQ stands for what's called aqueous solution. That means stuff is dissolved in water. So what are we going to do here? Well, we have to look and say, all right, I've got 2 hydrogens on this side, and I've got 3 on that side. So we need to look for the least common multiple of 2 and 3, which hopefully you know is 6. So how can I get 6 hydrogens? Well, if I put a 3 in front of that, that 3 multiplies the 2, and it would give me 6 hydrogens. I'll show you that schematically in a moment. Well, if I'm going to do that, I have to go on the other side and put a 2 over here, because in that case, I have 2 times 3. That's going to give me 6 hydrogens. And let's go ahead now and look at our nitrogens. Well, fortunately, I've got 2 nitrogens here, and that 2 distributes, and I have 2 nitrogens there. So everything's balanced using these coefficients. Let me draw this out for you schematically. So let's say now I've got 3 of these H2s, H, and I got another one here, H, and another molecule of hydrogen, H. And it doesn't matter that they're bonded together because those bonds will break and reform, and we don't have to worry about that right now. And I have my N2. And on this side, we're going to get 2 of these guys, N. And I'm just, again, this is not a very accurate representation of the shape of these molecules, but we don't care about that right now. So let's go ahead and count them up. I've got 1, 2, 3, 4, 5, 6 hydrogens, 1, 2, 3, 4, 5, 6 hydrogens, 1, 2 nitrogens, and 1, 2 nitrogens. And that's how we balance chemical equations. So they're not really, they're not that difficult to do. Just remember, you cannot touch your subscripts. These cannot be touched. You use coefficients. Let's see if I can pull up a worksheet here, and maybe we can look at some of these. Let's take a look at a very simple one like number 9 here. Nope, I guess I can't write on it. But if you take a look here, we have S with an 8 and O2. And so what we have to do here is we have to play a little game where we put the proper coefficients in here, and so everything balances. So what I would do here is I would say, okay, since I have 2 oxygens on that side and 2 on that side, we can go ahead and save this oxygen for the last thing that we balance. So on number 9, it's unfortunate. I wish I could write on this. Maybe I'll figure out how to do that here. If I have 8 of these, I can put an 8 over here. Maybe I can even type it in. No, it's not letting me type it in. Anyway, if I put an 8 there, then I'm going to have 8 sulfurs and 16 oxygens. So I'd have to go ahead and put an 8 in front of that oxygen there to balance my oxygens. So, as a matter of fact, this would be something good for you to try to play with. Let me make a comment on some of these things like NO3 and CO3. So let me go back to my whiteboard. And, well, first of all, let me go ahead and just copy this down. I've got sodium nitrate and lead oxide. So let me go back here. Go back, sodium nitrate and lead. Let me make sure I have the right oxidation state, the right charge, PbO. And we are going to see a situation like this. Now, sodium has a +1 charge. Oxygen or oxide has a -2 charge. So we're going to need Na2O. That's the chemical formula for sodium oxide. and lead has a +2 charge because oxide has a -2 charge. So I'm going to have this lead nitrate, but I need 2 of those because nitrate has a -1 charge. Again, this is what's called a polyatomic anion. We learned about those earlier, and that sticks together like a group. So notice that NO3 and the NO3 over here, they don't break up, they don't turn into other things, they stick together as a polyatomic anion. And so you just treat them as a group. Why is it doing that? So if you take a look here, we've got 1 sodium on that side and 2 on that side. Well, if I put a 2 over here, my sodiums are all balanced. So that's good. And notice that the 2 distribute. So I'm going to have 2 nitrates, which I have on this side. So that kind of falls out and is already correct. I have 2 nitrates. And on this side, I have 1 lead and 1 lead over there, and 1 oxide and 1 oxide. So merely by putting a coefficient on that side, right here, everything was able to be balanced. So it's kind of like a little bit of a game. You have to recognize polyatomic ions and understand that they stay together like groups. So this is a brief introduction to balancing chemical equations. As I said, you've probably seen it before. So if we go back and look at that packet of worksheets, there should be a page with balancing chemical equations. If not, if you want to go back and just look at some of these and recopy them and practice them, there's certainly a chance for you to go ahead and do that. And you're probably going to have some that cause you trouble, and that's fine. We will go over those as we need to. So take a look at this and see what you think. Let me know. Have a great Tuesday and a great week, and we're going to be wrapping this material up very shortly.